My name is Ioannis-Markou, and I'm a PhD candidate at the Department of Architecture and Built Environment at SETU Waterford, and I will present my conceptual framework for dynamic material passport for sustainable material management. So the built environment is one of the major contributors of CO2 emissions, natural resource depletion, and waste generation. So in order to reduce the environmental impact of the built environment, it is necessary to move from a linear model of take, make, dispose to a circular economy model of make, use, recycle. And based on that, the aim of this paper is to introduce the conceptual framework of dynamic material passport using BIM and AI techniques. And material tracking is very important for the built environment, as is enabling circular economy and sustainability, and by reducing CO2 contributing to the reduction of CO2 emissions and reduction of material waste. So the methodology employed for this paper is following the next steps. So the first step is carried out a horizon scan of which technologies, digital technologies, can implementing in the built environment and enable sustainability and circularity. It was carried out, in the Scopus and Web of Science, which, they are major peer review resources. So the second step is to identify the digital technologies. The most prominent, from the literature review, it was seen that, building information modeling and material passports were the most prominent. But due to the fact that there were many studies about BIM, it was concluded that material passports need further investigation, as is fairly new concept for the built environment. The step 3, we apply qualitative methods such as critical literature review to the current state of material passports, and then identify the gaps and challenges of implementing material passports in the built environment, and based on those gaps, the conceptual framework was developed. So a bit of a background on the literature. So what is material passports and how they implement what's the relation with circular economy? So as humans, have passports for identity, material passports give materials an identity and enable materials to be monitored and tracked. So basically, you can define material passports as digital data sets that enable materials to be tracked and also provide information about their origin and characteristics. From the literature, it can be seen that there is different levels of material passport. This is based on Waterman's material passport framework, which was recently published in November 2023. And it's a practice framework, and as you can see on the bottom, we have the material level passport and moving up to the area level passport. And material passports align, with the circular economy principles, as it allows materials to be reused and recycled, reducing the need of virgin materials for construction, and provide information about the environmental impact. So the data that included in a material passport can be manufacturing information, physical and chemical properties, quality-related information from material, design-related information, location of material, transportation, and disassembly manuals. And also, finally, but not less important is they provide sustainability information such as embodied carbon and circularity index. So material passports and BIM. So BIM constitutes a very powerful tool for the built environment. It provides a digital representation on the functional and physical features of the building asset and combines planning, design, construction, and asset processes. And it promotes collaboration between the stakeholders and by enabling data-driven decision-making during the whole life cycle of a building. The processes for creating a BIM model is described in the ISO 9650 series, where it specifies the use of industry foundation classes format, or IFC, which is an open standard for transferring, building data between BIM models, the various BIM softwares, and therefore enables interoperability as a common language. So linking material passports with BIM, what's the benefit of that? The combination of material passports with BIM is very important as it assists the comprehensive material documentation by providing accurate material quantities and building geometry and material location within the build model. Also, the integration with BIM, with the integration of BIM with material passports allows to linking, to secondary databases for physical properties and physical properties, and automates environmental impact like global warming potential and circularity. So material passports and BIM. Traditional methods of creating material passport require a lot of time, and it's prone to errors, human errors. Therefore, to assist, the collection and analysis of material data, it would be advantageous to link, material passports with AI technologies. Among AI, deep learning and machine learning are the most prominent algorithms that have been already implemented in the built environment in some circular projects and successfully contributed to the reduction of construction waste. So what's deep learning? Deep learning is a mimic of the human brain, and it can take decisions similarly to humans, and is advantageous for sustainable material management. Machine learning, on the other hand, can be analyzed and forecast data, and also assess, material consumption patterns. Therefore, it will be advantageous to further investigate, which will be from those techniques, will be advantageous for optimization and automation of material passport for enabling real-time updates and more accurate data. From the literature, various gaps, and challenges were identified, such as standardization issues, material accuracy and security, and also economic and social issues like lack of incentives of used material passports, and lack of motivation from the professionals, from the ECO professionals to adopt to new techniques. Although the focus of this study are the technological gaps, like the static form of material of current frameworks, which in terms of requiring a lot of manual input to be updated and compiled. Therefore, the technological gaps of material passports are summarized in the table on the current state, and versus the envisioned future state of material passports. So based on the gaps, showed on the summarized on the previous table, the following, conceptual framework of dynamic material passport is proposed. So the first step is to compile, the BIM 4D model based on the ISO 9650 processes to produce, the digital model and for the accurate quantities. Then we have the material inventory, which provides, the material attributes, such as characteristics, and those compiled, by AI processes, by AI techniques. It will compile the content of the material passport, dynamic material passport, that will be stored in the single access point acts as a common database, and then exported to a QR code. QR code will enable, the access to geolocation and also access to the application for automatic environmental assessment, and also access to the material data. So some limitations of implementing the conceptual framework, such as industry resilience, financial constraints, interoperability issues between, the different software, data accuracy and privacy, security, lack of standardization, and education and training. Finally, some conclusions. The framework aims to solve the static form of the manual input of the current state, and also the integration will be aligned with a newly published standard of ISO 9650. And AI, the implementation of AI and QR codes will allow real-time updates, and by adding life cycle assessment, we reduce the carbon footprint. And some future directions, like creating dynamic material passport prototype, a pilot case study, and then improvements. And thank you very much.